Hi, welcome to Spectroscopy with Pasco. In this short video, I'm going to present how to measure and to investigate emission and absorption spectrum. In the beginning, we're going to start with some concepts about emission and absorption spectra, and we are going to continue with some measurements for hydrogen, mercury, and for the light bulb. We are also going to calculate the wavelengths for hydrogen, mercury, and as a homework, we are going to allow you guys to determine the wavelength for LEDs, and we're going to provide some measurements for that. In this panel, we present the electromagnetic spectrum from short wavelengths to long wavelengths, including the wave type, and at the bottom, we present the visible spectrum from violet to red. The details of light emission from atoms involve the transition of electrons from higher to lower energy states within the atom. When an electron in an atom is boosted to a higher orbit, the atom is excited. When the electron returns to its original orbit, the atom de-excites and emits a photon of light. Each chemical element has its own unique set of energy levels, and each element also has its own distinctive pattern of spectral absorption and emission lines. This pattern can be seen when light is passed through a prism or a diffraction grating. Such an arrangement of slit, a focusing lens, and a diffraction grating is called a spectroscope, one of the most useful instruments of modern science. In this panel, we show the continuum spectra for a black body radiation or a light bulb, and a emission spectrum for hydrogen or mercury or neon, a hot dilute gas. And the last lower panel shows an absorption spectrum. We have a list of materials that are needed for building the spectrophotometer, an optical bench, a spectrometer base, the degree plate, and the light sensor arm. We're going to place the light sensor on this arm. The passport light sensor has 3 settings. We need a rotary motion sensor, an aperture bracket, and we're going to use this aperture bracket in front of the light sensor, two lenses, a focusing lens and a collimating lens. They are both of 10 centimeter focal length. Collimating slits, we have 5 different sizes for the collimating slits. A Pasco 850 interface. We also provide a list of tips and a experimental setup, and provided from the instruction manual, and please read that manual. It's going to be saved at the end of this presentation. So our experimental setup shows the location of all the elements: the light sensor, the rotary motion sensor, the diffraction grating holder, the collimating lens in front of the light source, and the collimating slits. So in order to measure the spectral line, we have to move the motion light sensor really slowly. All the elements are aligned. In front of the collimating slits, we place the light source, and if the light source has a large opening, we should mask the opening so it transmits a narrow 1 centimeter wide light beam. The light source should warm up at least 10 minutes before the start of the experiment, and you should adjust the light source such that the collimating lens the collimating slits, the focusing lens provide a very sharp image on the aperture screen, and you should see the central ray and the first order spectral lines. Now you have to be aware that because of the symmetry, you should see a left and a right spectrum, and they both should have the same lines. One side, the spectrum is going to be brighter than the other. So next step is connect the interface to the computer and connect the sensor, light sensor and the motion sensor to the interface.